This video continues on manufacturing of nanotubes, and we are going to talk about the last two technology involved in that. Uh, this is known as chemical vapor deposition, and what we use is we use either methane or depending on what sort of nanotubes you want. If you want it to be single or encapsulated within each other, you either use methane or ethane or carbon monoxide. Now it goes in, there is an oven or a furnace here at elevated temperatures, and you also have a substrate. That's the solid that is usually etched or engraved with some sort of catalyst. The catalysts are either iron, nickel, or cobalt. Now at that elevated temperature, this carbon is going to break, and that breaking is known as cracking in chemical terminologies. And you're going to produce these nanotubes that are going to grow on this solid surface. And it's a black color carbon soot-like, and those are your nanotubes. Now one very important question that you will definitely be challenged is, why don't we put oxygen into this? So oxygen should not enter this, because if you do so, then you will turn it into carbon dioxide and other impurities rather than produce nanotubes. Sometimes we inject it with a nitrogen, which is an inert gas, to blanket this reaction and to produce nanotubes. So chemical vapor deposition, this is how it's being done. There is another version of this known as high pressure carbon monoxide disproportionation, and I'm going to get into that in the next slide. So let's just look at it together. Now, high pressure carbon monoxide disproportionation definitely involves carbon monoxide that goes in. It's fed at the same time with a catalyst known as iron pentacarbonyl. It has 5 carbon monoxide. And what happens to this is, first you produce nanotubes of iron, and then the carbon is going to grow on that. So there is something known as nucleation. So eventually you will have your nanotubes being produced. Now the reaction is important, and what is disproportionation is carbon monoxide. So you have to be able to write this equation, which is simple. 2 carbon monoxide is going to produce your carbon in forms of nanotubes plus carbon dioxide. Now, disproportionations are reactions that the same species goes through oxidation and reduction. If you do oxidation number of carbon, in this case, this is +2. If you look at this carbon here, it's 0, it's isolated. So this is reduction. So carbon monoxide goes through reduction to give you the nanotubes. Now, if you also compare +2 to carbon dioxide, the carbon within carbon dioxide, which is +4, you see that is oxidation. So disproportionation is when the same substance is both oxidized and reduced.